Okay, here we're looking at one of the newer modules in Khan Academy. It's Computing and Scientific Notation. Here the goal is to get 5 correct in a row, and I'm going to walk us through some of these. Now, I'm going to tell you that I definitely made some mistakes here because what I was doing when I started this module was trying to solve it all mentally, which is not really a problem, except there's a lot of little caveats here to these problems, and you want to at least keep track of your thinking on paper. And in this type of module, I would encourage my students to have a calculator handy, but there are many aspects here that can be solved mentally. So let's go through this. Einstein's famous equation, E equals mc squared, states that mass and energy are equivalent. The speed of light, c, so they're telling you here that the variable c is for the speed of light, is 3 times 10 to the 8th meters per second. So, and here the mass of an object is in kilograms. So they're giving you those units right there, kilograms. E is the energy in joules. The mass of a 1 kilogram object is equivalent to how many joules of energy? Well, let's just plug this in, right? The C value is being squared, so it's, oops, that's not a good color to write in. I'm not going to use yellow. So C is 3 times 10 to the 8th squared times m, the mass of an object, which is fortunately just 1, and here it's kilograms, and here's your energy. I'm going to leave the units out though because we know that when we combine meters per second and kilograms, and we square this, we're getting joules. That's what joules are. They're telling us that in this. So I'm leaving the units out. Here, how do we square 3 times 10 to the 8th? Well, we square each piece. 3 is 9, and 10 to the 8th squared, that's just 10 to the 8th times 10 to the 8th. Here, using the laws of exponents, we can add those exponents, right? 8 tens being multiplied by another 8 tens is 16 tens altogether. And that's our answer here. So it's 1 times that, but 1 times this number is just itself. Sometimes I think students struggle a little bit here with the squaring of this number, right? But think about when you have, we're not adding these terms, right? If you had 2 plus 3 squared, well, this is not equal to 2 times 3 squared. These are in fact very different things. 2 times 3 squared is equal to 6 squared, or 36, right? Here, that means, and that's kind of what we have, which you're multiplying. You could square 2 to get 4, and square 3 to get 9, and multiply them to get 36. It's the same type of problem here. But 2 plus 3 squared is what? 5 squared is 25. So when you square two terms that are being multiplied, like here we have 3 and 10 to the 8th, you could just square each individual term. But when you're squaring two numbers that are being added or subtracted, you can't just, right, square each term. You've got to either add them and square everything, or use the distributive property, which we're not going to get into here. Okay, so let's look at maybe 1 or 2 more problems from this module so you get a sense of what's happening here. Okay, simplify this expression and write the result in scientific notation. So in a lot of these types of problems, the goal is to set it up so you can solve it in a simple way. And here, it might actually end up being simple, except you might want to use a calculator at some point. But we're going to attempt to solve these all mentally. So you want to play with these numbers a bit. We have 9.9 times 5 times 10 to the 4th. Well, 9.9 times 5 is not so bad to do mentally, right? Because you can think of 5 times 9, that's 45, and 5 times 0.9 is going to be the same thing as 5 times 9, except 0.9 is 10 times smaller. So the product here is 10 times smaller, or 4.5. You can see it, 45 to 4.5. We add those two, we get 49.5. So now we're breaking this down up here, right? We have 49.5 times what? Times 10 to the 4th. We haven't touched that one yet. I'm not going to write that in scientific notation yet, right? This number is too large. 49.5 is too large to be in scientific notation. I'm going to leave that for now and see what else we can break down. In the denominator here, we have 250 and 0.022. Well, this is where I think rewriting in scientific notation can really help. 250, we can think of that as 2.5 times 100, or times 10 squared. 0.022, we can think of that as 2.2 times 10 to the negative 2. And we're multiplying these two together, right? So 2.5 times 10 squared times 2.2 times 10 to the negative second power. And this seems difficult, except we can shift things around, right? I'm going to multiply 10 squared and 10 to the negative second power. Negative second, excuse me. And that's 10 to the second times 10 to the negative second. And then 2.2 times 2.5. 2.2 times 2.5 times 10 squared times 10 to the negative second. This is nice right here because if we add these two exponents, we get 10 to the 0. 10 to the 0 is just 1. So we're multiplying by 1. We don't need to even think about that. Now we have 2.5 times 2.2. You can do the long multiplication here, or this is one of those steps where it might benefit you to use a calculator. 2.5 times 2.2 is 5.5. So now we have this, right? 49.5 times 10 to the 4th over 5.5. So here we have 49.5 divided by 5.5. We want to figure this out. Well, I'm going to say it's about 9. Let's see if that works. And you can use a calculator, but I feel like here this might be nice to solve mentally. 9 times 5.5, we'll test that. Let's see if that's right. 9 times 5 is 45. 9 times 0.5 is 4.5. Altogether, it's 49.5, which is what we need. So yes, this is equal to 9. So now we have 9 times 10 to the 4th, and that's our final answer. So a lot of these problems you'll find seem incredibly overwhelming, and some of them do have a lot of tedious calculations in them. In that case, you can use a calculator. But try and rearrange things so you can solve them using what you know about the laws of exponents and what you know about basic arithmetic. Thanks.